All right, so I could right-click right here and choose Inspect. And where I just was led to is right here, so I could open that up and see, oh, there's Bootstrap. I'm going to change that right there. There we go. And now I go back and look at the page. Bootcrap is the most popular HTML, CSS, and JS framework for developing responsive mobile-first projects on the web. And I need to change this. Inspect. Bootstrap 4 is coming. And edit right there. And Bootcrap 4 is coming. And then I need to edit that one. Inspect. And where did that take me? Right here. There we go. And download Bootcrap. I should change that. People will see that. Download Bootcrap. All right. And then just for this screenshot, which I'm going to take, I'll change that, but I'm not going to go there.
Change that B to a C.
Huh?
Change that B to a C.
B to a C where?
Is that an image?
Where? Oh, right here?
Yeah.
No, it's fine, B. All right, so now I'm going to take a screenshot. And I don't know if I could get myself in legal trouble for this.
What the tab name?
Oh, the title.
Oh, that's
in the title head section.
all right. Inspect. Oh, I don't want to inspect in WebStorm. Crap. Coffee break. Inspect. So go up to the title. It's in the head. Title. Boot crap. All right. And then take a screenshot. And go to Twitter. And I don't know if will I get in trouble for this? Huh? Probably. Oh well.
Fair use for parents.
I know the lawyer. My wife is friends with this lady who's one of the main lawyers at Twitter. So if I get in shit, I got a friend. Tweet. This is how I tweet. Tweet. I wish people would just learn HTML, CSS, and JavaScript. This is a joke, obviously. Take a look. And if I offend the Twitter, let me know, and I'll desist. Remove this. I wish people would just learn HTML, CSS, and JavaScript. Oh, finally that opened up. Inspect in WebStorm. Wish people just learn. This is a joke, obviously. And attach some media. And desktop. Screenshot. Boot crap. Get myself in some sort of shit storm here. Huh. Not sure that it should be up there. I like it. We'll see what happens. We'll give it the class. I feel a little nervous though. I feel like I'm throwing mud. Because there are redeeming qualities to it. Huh? Maybe. All right, let's do some Go. So we left off passing data. And we did form data right here. So just a little bit of a review. We are parsing a template. Template, parse files, form. And that template is right there. And so the form is just first name, last name, and submit. And then we show some data. And then at any request that comes in, we're catching it. So at our domain. And we have our handler function here, handle func. And the request form value, so we learned about request form value, and so we're requesting first and last. and that comes off of right here, the naming the variable, first and last. And that's why I made this first and that first name, so you can see, oh, first is how we identify the name of the variable coming through. And then we're just printing out some information about first, just to play with it. And we're executing, and we're passing in a person, F name, last name. And the person is right here, first name, last name, right? And so we're just doing a composite literal of this struct. And if F name and L name, if this requests the form value and it's not there, right? So we go there and a form hasn't been submitted. What happens when that requests a form value and it's not there? Right? Are we passing in nil or are we passing in an empty string? So to figure that out, we could go to godoc and I feel bad about that Twitter thing. I'm going to take it down. It's just making me feel nervous. Whoa, I already got 2 hearts. What are my metrics on it? And 2 retweets. 40 people have looked at it.
It's too late.
It's already retweeted.
This is going to be, what do you say?
My epitaph on my tombstone when I get sued to the distant galaxy. Sued to a galaxy far, far away. So godoc. Yeah, thank you. I had a little brain fart. Some net HTTP, and we're looking for the request. I gotta get my game mind on. And here's the request, and we're requesting request form value. And so we can look down here, request form value. And form value returns the first value for the name component of the query. Post and put, body parameters take precedence over URL. So we're giving it a key string. Key tells me, maybe it's going to be a map data structure that it's looking at, right? And so if it's a map and we look up a value in a map and it doesn't exist, it returns the 0 value of whatever that the value is for the map, the key value. And so to figure out what that's looking up, I could go to form value. I don't know. Let's see what happens when I go to form value. So here's a form value, and I give it a key, and here's the key. So that's map syntax right there. So it's looking up our form and then giving it a key. So if I wanted to, I could go to the request form and see what that is, because that's what it's looking at. And so go back here and go to request form. Right here, and they're the URL values is what the form is. Form contains the parse form data, including both the URL fields query parameters and the post or put form data. So if I look at what that values is a map. Cool. So since it's a map, when I pass in...
It also mentioned in the documentation that it's an empty string on the way out in the paragraph.
Oh, do they?
Yep.
Did I just blast pipe? Where do you see empty string?
It was down in the form value area.
Right here?
Down below. The form value function.
Value.
Right above your cursor. If key is not present.
If key is not present, form value returns the empty string. But now we understand why, right?
Okay.
Yo.
So could an example of this that we would see in real life is if we are like logging on to, say, let's go with Twitter. When we start typing in like either our name or our username, our list would probably pop up that has our username or name. Is that basically what's going on here? Or am I?
No, that's getting into like Ajax, which we haven't gotten quite to yet. So this actually right here is actually a good example. When he's first going to this page, he hasn't submitted a form yet, so this form value locations are empty. But it's still going to this function. And he doesn't have to edit the function though, because it's returning an empty string. So when if he ran this and he goes to the web page, he hasn't submitted the form yet, but it's still executing this function because his handle func's handling everything. And so it's getting the empty strings back out for first name and last name there. And then when it executes the template, it's just sending empty strings in, and it's giving back to the web browser the web page, which is empty first and last names areas, and then he can fill in his form as he wishes, hit submit, and that'll come back to this page with the submitted form values, which it can then actually get something out.
Did that answer your question?
Yeah.
Cool.
We'll get to the live as you type connections to the server when we get to the Twitter project in general.
It's coming soon. It's about 2 weeks away, maybe a little less.
We gotta get the cookies in Ajax first.
Yeah.
Data store.
Yeah. All right. So let's just see it run. Maybe I should stand up. Change directories. And it's 3107. That's close enough. Game's gone. And then it's just printing out the string name. We saw this Monday.
Yeah, by the way, we've got this, which tells you where your current file's at, so you don't have to open this
Oh,
up.
sweet, man. Thank you. That's a good one. All right, so let's look at, now we're going to do form file upload. So the form will now be ink type multi-part form data. Post, file, choose file to upload. And we already saw uploading a file, but now it's in its own whatever, its own template. So parse the template, and then handle func, and if request method equals post, request form file. So instead of request form value, request form file, and we're asking for the file. And the reason we're asking for file is because right here, the name is file. It's not coming from ID, it's coming from here, right? So I could take that out. I don't think I'm using ID anywhere. Oh, I am,
For the form.
right there.
That should be the only place you're using it, though.
Yeah. And then we defer that source, the file, close that file. And destination error, we're going to create a new file. So starting from this current directory, file.txt will be the name, just a random name.
You shouldn't need that. You should be able to just say file.txt.
File.txt.
You shouldn't need the file path that join.
All right. And we'll run it both ways, see what happens. And then defer destination close, right? So we're going to close this file. So we created it. It's open. We got to close it. Anytime you open a file programmatically, you need to close it. So defers this line of code until this function here exits. When that function exits, all of the deferred functions run. Last thing to run. So it keeps the closing of the file close to where you open it. So programmatically, that allows you to check yourself and make sure I opened it. I need to close it. But it runs it when the function ends because you still need to use that. I still need to use it here, so I don't want it closed yet. So now I'm just copying from the source to the destination. So basically, I uploaded a file, and I copied the contents of that file to another file, right? A text file. And then I'm going to execute my template, and I'm passing in no data, and writing that to the response, and listen and serve 8080. So all I do is copy the file. So this is 310801. Choose file to upload. We need some more poetry. And we were looking at Rumi poetry, poems. Poems by Rumi. I don't know. I can't think of anything right now. This is a really good poem. Poem. I just can't think of anything.
How about that one, No Man is an Island?
I don't know that one. Some poem. I can't find a poem. Class continues. All right, we're already running. Documents, Go Workspace, Source, GitHub, goes to 11, Golang Web, and passing data, 08, 01, some poem. Submit. Cool.
So before you open that main.go back up, so I want to point out some of the this error here on line 43, 44. So this is, well, kind of how you probably want to do your error handling. The HTTP error function takes in the response. You can give it some sort of error message or string, and the error code, which 500 means server error. You'll generally, anytime you've got some sort of problem, you're probably going to want to call HTTP error and give it back some sort of error message and 500. Some people say you should not give back the actual error message because you want to keep some details about your server private, but you still need to have some sort of message to communicate to the user that, hey, something went wrong, we're sorry, we didn't get done what you're trying to get done. After you sent that out, you should print out for your own records the full error message, which is what that log fatal line is doing. I would personally prefer to use log print line instead of fatal line because you don't want to kill your server. You want the server to keep running afterwards. And then usually you'll type return too, so it doesn't try to keep going with your function. So in this case, it doesn't matter in that position, but in general, those 3 lines, if you ever have any problem in a web server, you probably want those. You're going to want those 3 lines in your. So something to tell the user something went wrong, something to tell you what went wrong, so you can figure out what went wrong and fix it, and then return so you stop trying to execute code.
Cool, thanks,
So
Daniel.
don't just crash. If you crash, then everyone can get to your website.
And we could see the error deal. HTTP error. Replies to the request of the specified error message and HTTP code. The error message should be plain text. And that's just the variable. It's just some string. Somewhere along the lines, things started clicking for me more with all this. When I was first learning Go, I'm like, how do we read the documentation? It's so confusing. All right, so the template, just choosing a file to upload again. And this time, parse it, post, request form file, defer, close, create a file, copy the file, execute, and what's the difference?
I'm not sure.
I did this when I was at home.
Oh, the
File path.
Okay.
So on this one, we don't have
This one on line 29.
we don't have the join.
Yeah.
OS creates just file text. What you mentioned.
Yeah.
And then O3.
there's something with temperature. Okay.
So this is a tempter, right? OS tempter, and OS tempter is, we could see information about that. We're going to print that out. And listen and serve 8080, and we could pass the handler right here. So just HTTP handler func, and HTTP handler func. HTTP type handler func is a function with that which returns this. That's kind of interesting.
That's the thing that it used internally.
Type handler func. Oh, there we go. Is handler func is this type. There we go. Use ordinary functions as HTTP handlers. So HTTP handler func. So we're casting this as a handler.
Basically, we're skipping the serve mux altogether and just saying everything goes here.
Different way to do it. Request form file. My file that comes from the template, which is down here. My file. OS create. File path join. OS tempter. File text. So we're going to put this into the temp directory and then copy it. And we've just put everything right down here, all of our HTML instead of a template, and setting our header. So this one is 03. We'll do the same one. Submit. And it should have shown me a little bit of information about my tempter, var, folders, Z8, all that, T. Kind of crazy.
Don't have to CD, and you can do ls with the folder name. ls space that.
I'll do a new tab.
But yeah, if you want to go to another tab, that works too.
And we called it file.txt. So we can nano file.txt. There it is. We could also remove file.txt. Gone. Kind of interesting, tempter.
Temporary directory is supposed to be cleared out by the OS every once in a while, so it's good for if you've got your multi-gigabyte file or something that you need to process, you can dump it in your temp folder while you're processing, so it's not all in memory at once.
I feel bad about it. I think I should take it down.
Media engagements. Media engagements.
I don't even know what that means. What's that mean?
I don't either.
It's like it's on CNN now. It's pretty funny, but how many people look at this and you know what that means? How many people look at this and it still mystifies you a little? Okay, cool. It's just good getting the temperature of the room. So IO write string. Where would I go at godoc.org to see that? What I add in there? Right here. What I add in to see IO write string? How do I get there? IO. It's all pretty much organized by package. Net HTTP, I just enter, well, you know, it'd be HTTP in my code, but I'd have to enter net HTTP. So my code right? I look at what my imports are, and that's what I enter at GoDoc to get there. And so we're looking at IO write string, and there's write string. It takes a writer and a string. We've already learned what writer is. So writer is that interface, and anything that implements the methods or the one method in the writer interface, type writer interface, is implicitly implements the writer interface, and so we could use it there. So we have a IO write string response. So our response is from this function here. It's a HTTP response writer, and that function goes from here to there. And by the way, I call this casting. It's actually conversion. There's conversion and assertion in Go. They don't really talk about it as casting. It's conversion. So we're converting it to the HTTP handler func type. And so IO write string takes a writer and then a string. Here's the string I'm writing. I'm writing that to the response, to the web response. Okay. So it's basically the form stuff that's being written. And I'm setting this up here, the content type, for the response to text HTML, so it displays as HTML. And I'm doing this because it's not a template that has HTML on it with the doc type and all of that. Okay. And then listen and serve, my handler func, my function. Here's most of the code. If it's post, request form file, my file, comes from right here. The naming the variable in the form. So we're requesting that if the method is post, meaning the person has posted this form back to this page. So we know the method is post. That's one of the things. Get, post are the different methods. So we get a page. Like if I just go to a page, go to the network tab, request this page, and if I look at that, it says, hey, my request method was get. If I submit a form, right, my request method might either be, is it get?
It's either get or post.
It's get or post. Is it MDN form?
Set it to put as well.
This is what we looked at yesterday, Monday. Post. Yeah, post or get. So the post is goes through the form background, and get goes through the URL. So I could send the form data get, but I've chosen to send the form data post, method post. So if my method coming in is post, I know somebody just submitted the form. So get this request form file and get that file, which was named right here.
I don't think you can use get if you're using a file.
Probably not. So defer file close, and then limit reader. It's only read some of it.
We haven't
So
really covered that in too much detail yet.
you want to talk about limit reader, or I'll bring it up. IO limit reader.
So limit reader was a result of what happens when someone uploads a multi-gigabyte file or something, and you're suddenly running out of hard drive space or RAM or whatever. So limit reader is a nice, easy way to basically kind of wrap around some reader and stick a limit on how big it can be. So limit reader there, it takes in a reader and some number and returns another reader. So all it will do is you give it like your reader, like your, in this case, the file, and then some sort of maximum size in bytes. Like I think we've got in the code, we got it set to like 400 there. It means it'll stop reading after 400 bytes. It'll say that's the end of the file. It doesn't matter how much there is left in the file, how much left there is actually in the file. After 400 bytes, it'll stop. And that way you don't have to worry about running out of memory or something if you decide to read everything.
I just gotta listen to my heart, dude. My heart doesn't feel good about this.
Everybody posts stuff like that on the internet. Nobody's
Yeah, but you know, when you don't feel good inside yourself, like you're throwing mud, I mean, that's somebody's baby, right? They've created boot crap, and they're happy about it. It's really interesting just kind of feeling that inside myself. Nobody likes to be made fun of.
Right, so just to refresh my memory, the write function writes from like your machine to the server, and the readers are if you're going in the opposite direction, if you're going like from your internet to
Writers can be writers and readers can be from anywhere, but basically readers are reading from somewhere not your program, and writers are writers are writing somewhere else outside of your program.
Yeah, writers write, readers read.
So that can be an internet connection, a file, something. But in general, though, readers will read from somewhere outside, writes will write somewhere outside.
Writers write, readers read, and
if you don't trust your source, don't read everything. Use a limit reader to stop it after a while.
and the writer is a type, it's an interface, and things could implement that. And the reader is a type, and it's an interface, and things could implement that if they have the write or the read method. And then we have a whole bunch of different functions which take writers or readers. Right? So we have IO write string. I could have also used fumped fprint, and fumped fprint is for file print, and file print takes a writer. So I could have said, well, my response is a writer, right? Let me use fprint and pass and say, where do you want me to write to? I want you to write to my response. Where do you want me to print this to? Print it to the response. What's a response? Well, the server's received a request. It's making its response. So it responds back to the client, sends that back on the HTTP response writer. HTTP response writer, right? So you could use all kinds of different things. We used IO write string. You could have used fumped fprint, and there's even more.
IO write string is probably going to be faster than fprint because write string already knows that it's a string, whereas fprint has to figure out that it's a string and then before it can actually send it.
Here's copy. Takes a writer and a reader. So we could, put our response in as the writer. And for a reader here, we could pass something in which implements the reader interface. And so that could be a file, right? Here we're passing in a file, the source that we opened. We could also just pass that file in straight to the response. So instead of destination, I could say write that to the response and write that back to the HTTP response writer because that implements the writer interface. So interfaces, writers, readers being examples of them, allow polymorphism in Go, which takes a little bit of time to wrap your head around, because I could stick in all kinds of stuff to IO copy. IO copy takes a writer. Whatever implements the writer interface, I could stick in there. And it could be a lot of different things. It could be a file. It could be an HTTP response writer. They have different functionality. But however they've implemented that write method so that they're implementing the writer interface, that's what gets run when copy says, okay, I'm going to write using your write method now, and it's different functionality. But all of them could be used there because they all implement the writer interface. So poly, mini, morphism, different morphing. So it allows polymorphism in Go. How many people feel like this is pretty challenging? Raise your hand. Cool. Yeah, I think it's a very good challenging though, because it really suffers no fools, and it isn't Bootstrap, it's not jQuery, it's not Ruby on Rails, it's not PHP. This is programming, and you have to understand interfaces, and you have to understand polymorphism, and it really forces you to know your game as a programmer, and not just rely upon, okay, I understand this framework or this library and I could make it work. Like if you understand programming, you can understand this. And when you understand this, you'll understand programming. This kicked my butt up and down the street when I first started working with it. There's a guy who's one of the top authors for Go programming and one of the top evangelists for Go. He said, I didn't understand the language spec for 6 months when I first started with Go. So it is something that really forces you to, know what you're doing. And take inspiration from me, because I only started learning this a year ago. I knew very little about programming when I started learning it. Okay, now check it out. Like a year ago, December, I started learning it. Count your blessings, you're in the 3rd class. That's passing data. How many people enjoy it? Oh, cancel that.